So suppose I'm having a system which is second order. If I add a pole to the system, it means we are modifying the system. We are modifying the system. Then it becomes third order. Its characteristics will be modified. Similarly, in the system which is shown here doesn't have any zero. Doesn't have any zero. If I add a zero to this system, means again we can modify its characteristics. That we are going to see today. First, let us see the effect of adding a zero to the system. The original system is this. This is the original system. This is the original system. It doesn't have any zero. But I want to alter its characteristics. I want to alter its characteristics so that I am adding some additional zero to that system. So this S plus Z is added to the system. S plus Z is added to the system. So we will add some additional components in our systems. If you buy some vehicle, they will tell some set of add-ons. You will buy and add. Like that, if we cascade some other system, then this will be added. For example, I am having a system which is second order. If I cascade like this, in a block diagram reduction, what we'll do, we will multiply these two. We'll multiply these two. Like that, if you add a system that is called, by doing this, we can alter either poles or zeros. The first thing is adding a zero to that system. So I am having a separate another system which has a zero, S plus Z, which is cascaded with this. If you cascade like this, what will happen? The new system becomes like this. The new system becomes like this. Because if you cascade, this is another system. This is the original system. This system has to be controlled. This system has to be controlled. The first system has to be controlled. Second system is added, cascaded to that to modify its characteristics. It is only to modify its characteristics. That's all. That additional system is S plus Z upon Z. Why that Z is S plus Z divided by Z? Why means if you simply add S plus Z, its gain will be affected. Its gain will be, static gain will be affected. But I don't want to change any of its static characteristics, static gain. I want to simply add the zero only. The effect of zero alone must be there. That's why S plus Z upon Z is added here. If you add S plus Z only, then its gain of the system will be affected. Gain of the system will be affected. To avoid that change in gain, static gain K of the system, to avoid change in K of the system, if we divide by Z, S plus Z upon Z. If you put like that, there won't be any change in gain. Then what happens to the system? Now the modified system is S plus Z omega n square upon Z S square plus 2 zeta omega n S plus omega n square. This is the modified system. This is the modified system. This is the original system. Original system. The modified system, we added a zero. Where? 0 is added at minus Z. Z may be 1, 2, 3 like that. A 0 is added. What is mean by 0? Roots of numerator polynomial is called zeros. Roots of numerator polynomial is called zeros. What is mean by pole? Roots of denominator polynomial. Roots of denominator polynomial. Yesterday we have seen if roots of denominator polynomial on the right hand side, system is unstable. System is unstable. Any of the poles, at least one pole. Suppose the system is third order. How many poles will be there? 3 poles, because denominator polynomial will be third degree. 3 poles will be there. If one pole, at least one pole is on the right hand side, means unstable. For all the poles must be in the left hand side. In other words, the poles, real part of the poles must be negative. Real parts of the pole must be negative. Then it automatically it will be in the left hand side of a split. Definitely the system will be stable. That we have seen. But 0 can be either on the right hand side or left hand side. No problem about stability. No stability issue, but the dynamic issue will come. But stability issue will not come if 0 is on the right hand side. 0 is on the right hand side. Only poles must be on the right hand and left hand side for a stable system. Here modified 0 is added at S equal to minus Z. Why I am saying S equal to minus Z? S plus Z is added. What is the 0? S plus Z equal to 0. How to find 0? The numerator polynomial S plus Z equal to 0. That is equal to S equal to minus Z. Is the 0 added? This is the 0 added. Then what happens to the system that we'll see? Then what happens to the system? S plus Z omega n square upon Z whole divided by S square plus 2 zeta omega n S plus omega n square. This can be separate like this. If you bring Z, this part, if you take this part alone, if you select this part, Z omega square n upon Z, if you select, you will get this. You can separate this into 2 parts. You can separate this into 2 parts. S upon Z. This is equal to S upon Z upon S square plus 2 zeta omega n S plus omega n square plus Z by Z. That is omega n square upon S square plus 2 zeta omega n S plus omega n square. So you can separate this into 2 parts. In the first part, you will get omega n square. That is the original system. This is the original system. Plus S upon Z multiplied by original system that you got. Let us assume that the step response of this first part is C of t. Let us assume that step response of the first part is C of t. Then what is the step response of second part? The second part is multiplied by S. In the S domain, if it is multiplied by S means in time domain, it is derivative. Therefore, I can say d by dt of C of t. Can I say like that? Because in S domain, if you find d by dt of C of t equal to what? S C of S. Am I correct or not? If we take Laplace transform of derivative of some function is, if you take Laplace transform of derivative of a function, then you will get S C of S. Therefore, S is nothing but the derivative. So I can write d by dt of C of t multiplied by 1 by Z. Therefore, the response for this system is this. Therefore, C of Z means compensated system. The response of uncompensated system is C of t. Response of the uncompensated system is C of t. The compensated part, S plus Z part, that is separated in two parts. One is the original system, another one is with S. That gives this component. So the response of the original system is C of t. Response of the compensated system is C of t plus 1 by Z d by dt of C of t. Derivative of C of t is added. Because of adding a 0 to the system, the response is modified like this. The response is modified like this. C of t is modified as C of t plus 1 by Z d by dt of C of t. So if you see the response, if you see the response, this is compensated system, C Z of t. This is the original system, C of t. Original system is, original response is C of t. After compensation, what is the change? What are the change in the time domain specifications? What are the changes in the time domain specifications? What are the changes in the time domain specifications? Here, what is this? This point is raise time. Do you know that? Raise time means what? Time taken to reach final value first time. Time taken to reach final value first time. Here, this 2 is for original system. 1 is for compensated system. If you see for 1, TR compensated system. TR compensated. This is TR original. TR original. Raise time is reduced. Raise time reduced means what? It quickly goes to the final value. It quickly goes to the final value. Therefore, the system becomes smart. The system becomes smart. What we are saying, if the system takes a long time to reach final value means sluggish, we are telling. The system quickly goes to the final value, even if it oscillates, it is smarter because it quickly reaches the final value. But oscillatory, this compensated system quickly reaches the final value first time. That is, raise time is reduced. Smart system. So if you add a 0 to the system becomes smart. What is the drawback here? Overshoot is more. Notice that overshoot for the original system is this much. Overshoot is increased to 1.7. Overshoot earlier is 1.4 only. That is 0.4. Overshoot is 0.4. Now 0.7. Large overshoot. But if we select the value of Z, we can adjust that overshoot. We can adjust the overshoot. If we select Z very close to origin, very close to origin means smaller value. Am I correct or not? Z small value means what is we are finding? S equal to minus Z. If I select S equal to minus 0.5, that is very close to origin. If I select S equal to minus 5, far away from origin. If I select Z very close to origin, overshoot will be large. Overshoot will be large. If select large value of Z, overshoot will be less. This we can understand from 2.54. What is 2.54 says? C of t. This is original response. C of t is the original response. Am I correct or not? It doesn't give any overshoot. It is sluggish. It is sluggish. If you add this, because this additional component, this raise time is increased, overshoot is higher. If you put Z in the denominator, overshoot will be less, definitely. Large value of Z means overshoot will be less. So, if we select Z far away from origin, large value of Z means overshoot will reduce. If you put 0.5, what will happen? 1 by 0.5 means it will increase the overshoot. 1 by 0.5 equal to 2. 1 by 0.5 equal to 2. Overshoot will increase. 1 by 5 means 0.2. Overshoot will decrease. So if we select Z far away from origin, we can adjust the overshoot. By selecting appropriate value of Z, we can control the overshoot. At the same time, the system becomes smart. Smart means the rise time is minimum. Rise time is minimum. But one more thing you can notice, even though the overshoot is there, it settles quickly. It settles quickly. Notice that the overshoot is for daughter line is earlier than overshoot is earlier, not after this black. So it quickly settles. Even though overshoot is large, it quickly settles. So we can modify the characteristics of the system by adding additional system. By adding a 0, we can make the system smarter than original. We can make the system smarter than original. That is called addition of 0 to the system. We can adjust the overshoot by selecting appropriate value for Z. That's all.